Starship 39 has been sitting inside Mega Bay 2 for over 2 months now. It was fully stacked back in November, yet it still hasn't rolled out for testing. What's causing the holdup? Here's what most people are missing. SpaceX just completed a complete overhaul of all 18,000 heat shield tiles on this spacecraft. This isn't a delay, it's preparation for something historic. Could this upgraded thermal protection system be the breakthrough that finally makes rapid reusability real? Let's dive right in. The truth is, there are two calculated reasons SpaceX kept Ship 39 locked inside Mega Bay 2, and both reveal just how strategically they're thinking about Flight 12. First, SpaceX is building a dedicated support structure at the Massey site, what engineers are temporarily calling the truss structure. This isn't just another piece of hardware. It's designed to enable faster, safer, cryogenic proof testing and static fires, cutting down turnaround time between test phases. Ship 39 won't roll out until this facility is complete, which should happen within the next 10 days. But there's a second, more urgent reason that tells us everything about SpaceX's current priorities. Remember the Booster 18 incident at Massey? That explosion happened just a week before Ship 39 was completed, and it triggered a strategic shift across the entire Starbase operation. SpaceX realized the moon mission timeline was tightening faster than expected. They couldn't afford standard testing delays anymore, so they made a bold decision: use the extra time to accelerate Ship 39's readiness rather than rush it through incomplete testing. The first evidence appeared on January 2nd. When Mega Bay 2's doors opened, Ship 39 emerged surrounded by extensive new scaffolding. This wasn't routine maintenance. Workers were accessing every section of the spacecraft's exterior, focusing intensely on the thermal protection system. What were they doing up there for weeks? They were perfecting the heat shield. And this is where things get technically fascinating. Ship 39 is the first V3 Starship, and SpaceX is actively experimenting with creating a thermal protection system that's both incredibly resilient and truly reusable. The goal isn't just to survive reentry, it's to survive it repeatedly without extensive refurbishment between flights. Think about what that means operationally. A Starship completes its mission, lands back on Mechazilla's chopsticks, gets stacked immediately with a waiting Super Heavy booster, refuels, and launches again within hours or days. That's the vision driving every decision here. But could SpaceX use something like Dragon's proven heat shield technology? After all, Dragon has flown dozens of ISS missions successfully, using Pika-X material that ablates to handle temperatures between 1,600 and 2,000 degrees Celsius during re-entry from low Earth orbit. The problem is, Dragon's heat shield needs inspection and partial replacement after every flight. That's acceptable for crew capsules flying occasionally, but it completely contradicts Starship's rapid reusability requirements. Here's what SpaceX actually did instead. Originally, they planned for Flight 12 to continue the aggressive testing pattern used throughout 2024's 5 Starship V2 flights. That strategy involved deliberately removing tiles in key areas, stripping away the ablative layer underneath, and combining it with extreme maneuvers to push the spacecraft beyond its design limits. If it survived, that would prove the basic design had more margin than anyone expected. Those brutal tests taught SpaceX exactly which areas could handle flight without full tile coverage and which zones needed reinforcement. That's why they spent extra weeks installing additional ceramic tiles in those critical spots on Ship 39. But the installation work alone couldn't account for all the time spent in Mega Bay 2. Something bigger was happening. Enter Crunchwrap, and yes, that's its actual nickname, borrowed from Taco Bell's menu. This flexible, ablative sealant represents one of SpaceX's most important thermal protection breakthroughs. It fills gaps between tiles without traditional gap fillers, preventing superheated plasma from penetrating into the stainless steel structure underneath. Crunchwrap debuted on Flight 10, applied mainly to the nose cone as a fabric-like layer that sealed tiles and trimmed edges flush. Elon Musk praised the results afterward, saying the new heat shield performed significantly better. Flight 10's data showed crunch wrap worked well in most areas, preventing serious tile wear or oxidation, though some spots showed orange residue on the edges, evidence that refinement was still needed. By Flight 11, SpaceX expanded crunch wrap coverage significantly. Now on Ship 39, they've gone even further. The material is being applied extensively across the body and control flaps, creating a comprehensive sealing system that addresses the main vulnerability exposed in earlier V2 flights. If Flight 12 succeeds with this enhanced thermal protection, it validates the approach for the entire V3 fleet and clears the path for ship-to-ship orbital refueling tests by mid-year. But here's where SpaceX's iterative testing philosophy really shines, and where they learned a hard lesson about what doesn't work. During Flight 10, SpaceX quietly tested something radical. They replaced several hexagonal ceramic tiles with metallic versions made from heat-resistant stainless steel. The concept seemed logical. Metal tiles might offer better durability and easier integration with the steel airframe. Reality had other plans. According to Musk himself, those metal tiles reacted catastrophically with superheated oxygen during reentry, causing severe oxidation that left massive orange discoloration across the vehicle's midsection. Starship still landed precisely in the Indian Ocean, but the visible damage sent a clear message. Metal tiles threaten the rapid reuse timeline because even minor damage requires time-consuming refurbishment between flights. By Flight 11, SpaceX abandoned metal tiles entirely and doubled down on refining ceramic thermal protection. But they did something even more extreme to gather data. Engineers deliberately removed approximately 72 ceramic tiles across 18 of the hottest regions on the spacecraft. No ablative backup layer underneath, just bare stainless steel exposed directly to reentry plasma temperatures exceeding 1,400 degrees Celsius. Why would they sabotage their own vehicle like this? They wanted critical data for developing lighter, more efficient heat shields in the future, possibly systems that don't even need complete tile coverage in certain areas. They pushed everything to the absolute limit, and honestly, many observers expected potential loss of control or catastrophic failure. Instead, Starship delivered a shocking performance. The vehicle held together far better than predictions suggested. Post-flight analysis showed only minor discoloration, significantly less severe than Flight 10's damage, likely a direct result of the intentional tile removal strategy. What does this tell us? Starship's underlying structure is remarkably resilient, even under punishment that would destroy most spacecraft. Both recent Starship flights that re-entered atmosphere without losing control survived, sending a powerful signal. SpaceX is closer than ever to achieving true, rapid reusability. For Flight 12, with the heat shield in its best condition yet and crunch wrap sealing comprehensively applied, we're positioned to see just how far this vehicle has matured. And SpaceX is racing to get the infrastructure ready for what could be a historic demonstration. On January 6, the QD arm extension for Pad 2 was rolled out to the launch site. This massive hardware is responsible for fueling and stabilizing Starship once it's stacked and ready for launch. What's remarkable is the installation pace. Despite its enormous size, by January 8th, the QD arm was nearly fully installed. That same day, SpaceX lowered Mechazilla's chopsticks to run movement tests, swinging them through their full range to verify the stability of recently upgraded actuators. But the QD arm wasn't the only hardware being rushed into place. SpaceX has also been installing additional clamp arms on the orbital launch mount at Pad 2. These clamps hold the full combined weight of Super Heavy and Starship during fueling, pre-flight checkouts, and engine startup before releasing the stack cleanly at T0. By January 8th, 12 clamp assemblies were already in position. All this rapid parallel construction work points to one conclusion. Flight 12 may be coming sooner than most people expect. There's also a critical political development that directly impacts SpaceX's timeline pressure. Recently, Congress pushed back against President Trump's proposal to cut NASA's budget by roughly $6 billion for fiscal year 2026, which would have reduced funding to approximately $18 to $19 billion to prioritize defense and economic spending. Bipartisan committees reached a different agreement under a minibus spending package, allocating about $24.4 billion to NASA, only a modest 2% cut compared to 2025, while protecting core space exploration missions and STEM education programs. Why does this matter so much for SpaceX? SpaceX is the primary contractor for NASA's human landing system, with Starship selected to land astronauts on the Moon during Artemis 3, currently targeted for 2027 to 2028. A stable NASA budget means those multi-billion-dollar contracts remain secure, and it does something more important. It keeps pressure on SpaceX to accelerate Starship development while also strengthening America's competitive position against China's rapidly advancing space program. China is pushing forward with its Tiangong space station and targeting crewed lunar landings in the 2030s. A fully funded NASA Artemis program means SpaceX has both the financial backing and the strategic imperative to make Starship work, soon. At the same time, stable NASA funding allows SpaceX to expand commercial ventures like Starlink and private missions while reducing financial risk by leveraging NASA's infrastructure and long-term support. So here's what it all comes down to. Ship 39 represents SpaceX's most refined thermal protection system yet. 18,000 tiles meticulously installed, crunch-wrap sealing applied across the entire vehicle, and lessons from 5 brutal V2 test flights now baked into every design decision. This isn't just another test flight. This is SpaceX attempting to prove that full reusability is actually achievable. If Ship 39 survives reentry with its complete heat shield intact, we could witness the first Starship catch by Mechazilla. That would be the moment everything changes, when Starship transitions from experimental prototype to operational spacecraft capable of flying again within days, not months. The political landscape just gave SpaceX exactly what it needed to. With NASA's budget secured at $24.4 billion and Artemis contracts locked in, there's no excuse for delays. China's pushing hard toward their own lunar program, and America's response depends heavily on Starship succeeding fast. Flight 12 could happen within weeks. The infrastructure at Pad 2 is racing toward completion, and Ship 39 is getting closer to rollout every day. Will this be the flight that finally demonstrates rapid reusability? We're about to find out. If you found this breakdown valuable, hit that like button and subscribe to Space Update 24 hours so you don't miss Flight 12's coverage. Drop a comment below. Do you think Ship 39 will nail the Mechazilla catch? Let's discuss. Thanks for watching, and I'll see you in the next one.